Hello and welcome to Pentest blog. This is the third chapter in exploit development series. Today we are going to look into binary exploitation countermeasures and bypasses. We will try to bypass the NX enabled countermeasure. To make you understand the topic, I have made a simple presentation also. So let's start. So here is bypassing NX. So first we will see what is NX is. So NX is basically no execute bit. The no execute bit is the most popular countermeasure that can be found in the modern software pieces. So the basic thing is to make the data on the stack non-executable. That is no execute bit or NX bit or NX enabled that we will see. Okay, so in the next slide, we will see like how we will bypass the NX. So as we in our earlier videos, if you have not seen our earlier videos, please go to the suggested video and see the previous videos so that you can get an understanding. So during the Stack Overflow, we are controlling the data pushed on the stack as it is overflown with our custom buffer. So in order to bypass the NX protection, we can supply function arguments as part of the buffer and then make the EIP point to another function that will utilize them. So the idea is like the stack is non-executable, but we are controlling the EIP, right? So we can put the address of an executable binary in the place of EIP. So we will see how we will do it. So we will use the libc binary that is easily available in any Linux system. So libc is the standard C library in Linux which is present on all systems by default and contains some basic functions required for programs to run properly. Okay, so the final process like this, what is our procedure to bypass the NX enabled? So in order to execute a function that is in libc, we need to find an interesting function that will provide us with a cell. Okay, so first we need to find a binary that will provide us the cell, and we have to write that address into the EIP, so our program will jump to that address. So this is the theory part. Let's jump into hands-on and stay with me. Let's see. So here is our world.c. This is the same program as we are using from our previous videos. So this is the same function, the same line of code. You can go through our previous videos to get an idea. The basic thing is we are creating a variable of size 500 byte and we are trying to read 700 bytes, so there is a stack overflow. First we need to compile this code, but before that I want to say a little bit extra here. Like, so first we need to disable ASLR in our system. So this is already disabled. There are three possible values, 0, 1 and 2. 0 means disabled, 1 means enabled, and 2 means enabled with segment randomization. So if you do not know how to disable it, we will say like echo 0 and pipe that to sudo t, and we have here. So it will need the I have given wrong password. So okay, so now it's 0. So first we need to compile our code. Okay, so no stack protector, and it's compiled. we will see, and we will run the binary, and we will put something here, and buffer content is this. So we will check in the binary if NX is enabled or not. For that we will use a program called checksec. So checksec file, and our file is one. So here it is, NX is enabled. If you don't have checksec in your system, you can easily sudo apt install checksec, because I have already installed. So we will load this binary into gdb peda. So gdb, please to see like how to install gdb peda, please see our previous videos. One. Okay, so we will open our new terminal to generate our payload. So we will create a file here, like new file, exploit.py, and we'll first import sys, because we are going to work with Python 3, and we will first off, and we will save it. First we need to, let's recap like what is our offset here. So first we need to create the pattern. We can use the peda functionality like p pattern create. We will give 600 and the name of the file there where we want to store it, and we will run the binary by importing pattern, and we got a 6-7. Now we will locate the offset, and for that the command is pattern offset, and that does. So we are here, the offset is 516. So let's go here, we will just do this, and our offset is 516. Off is equal to off plus e sys dot stdout dot buffer dot write and buff. So we will see like this should be in our EIP. So what we will do here is Python 3 exploit.py, and we will save it to payload.txt. Okay, what's the error? So it should be outside the, okay, yes. So now if we there, and now what we will do, like we will run again and give the input. Instead of pattern.txt we will give payload.txt, and we can see the EIP has been overwritten by our P. So we are controlling the EIP. So to get a little more idea what is happening, we will add some more bytes here, and it's DDD. So this is, and now we are again generate the payload. Okay, again, okay. So and now the payload has been created successfully. Let's say yes. Now we will run it again with the payload, and again our the EIP has been overwritten by B, but this time we will see like what's in the ESP. So ESP, and as you can see, here is the C, and here is the D, and here is the E. So to get a code execution, what we need to do, like we need to find a binary which is executable, and then we need to put that binary's address in the EIP, so our program will jump there, and we need to put the return address in the place of C, and the arguments for that binary will go in place of D and E, this thing. So we will cover the basics here. So first let's find the libc binary, and here you can see the address is this thing 4C88. So this is the system offset. Now we need to find the base address of the libc library. There is another way, so we will go the easy way, and so there is a function in pada like v vmap libc. So we will pick up that address where there is an execute bit is there. So this is right for us. Here you can see the X bit is set, that means it's executable. There is another way of getting the address directly, and that is the P command. So we want to get the system, and the system is here. And the second thing, this address will be the EIP, and our return address will be exit, that is this thing. And so first let's craft the payload. So here we go, EIP, and we will craft this x80 xc8 xc4 and xb7. The second thing is our return address, that is to the exit function, and that will be this thing. So it will be x80 xc1 xc3 and xb7. Okay, so let's craft it. We will only pick up the address, and we will give here of the address. and we'll give you. So this is going to be our EIP, and this is going to be our, okay, how the two are same. X80, it will be C1, and C3, yes. So this is our EIP, and this is our return address. And the system function, we need to provide argument to the system function, and the arguments will go in here. So what we need to do, like we need to find a program that will give us a reverse cell. So for that we need to find bin sh, bin bash, bin zsh. So let's find bin in peda, and there are functions in the stack also, but we will use the generic libc binary. So we will use this thing, and ribcell and xc8 x5f and xdb xb7. So c8 5f dbb7. Okay, we will put it here and we will remove it. This thing, just start our payload or generate our payload again. So we will python payload, and here is our payload. So we will run it, run payload, and we can see like the program has been exited successfully because we have provided a perfect address of the exit function. But why didn't it give us a reversal, right? Because we have provided the bin sh as a argument. So it's actually the cell has been a spawn, but we didn't provide it any input. It got exit, right? So we need to hold that thing in here. So for that we will use a trick. So to hold the cell we will use a trick using cat. So first we need to now we will run the payload outside GDB. So payload txt, and we will pipe that to 1, and you can see it, like the program executed without any error. So what we will do, like cat payload.txt, and we will provide cat and pipe that to 1. So now here we got our reversal. So this is for how to bypass NX enable. There will be more advanced concept. This is only basics. So please let us know your review on this video, and please like, comment and subscribe so that we got to know that you like our video. Keep hacking. All the best. Bye bye.